So today we need to introduce to you the last of the trig functions. I mean the last of them. We're the first of them, sine, cosine, and tangent. You've been doing those for years. But did you know there's actually 6 trig functions? There's actually 6. Sine and cosine and tangent, which I know you've known as SIN or COS and TAN, but these are their full written out words. What does that tell you about the existence of maybe some other functions? At least one is just begging to be known. Think about it. If there's sine and cosine and there's tangent, what do you think there might be? Cotangent, yeah. There's something that kind of goes with tangent. It's a co-function, it's called. So there's cotangent. And then there's 2 last functions that you've never even heard of before. But I also want to bring this to like a full circle here and say there's 6 trig functions, but really, yes, full circle, like it. There's really only one. Did you know that all of these can be boiled back down to sine? Even cosine. I know a lot of you know that tangent, by now you figured out that that's y over x, also known as it's sine over cosine. So if your tangent button was broken, you could get the answers from sine and cosine. But did you know that you really only need cosine? It's kind of weird, but it's true. I said cosine, but I meant sine. Sine is what they're all about. They're all about sine. Why? Because if you look at the sine graph, it's a wave. We aren't in the graphing unit yet, but that's kind of how sine goes up and down and up and down. It keeps on going forever. And it goes in both directions forever, so it keeps going this way. And anyway, but cosine is just sine except shifted over. There's the graph of cosine. It's pretty much sine except shifted. All right, here's another thing you probably didn't know about sine and cosine. Those are called cofunctions. And if I said the sine of 20 degrees, it would be the same as the cosine of 70 degrees. Because they're just shifted a little bit. How far are they shifted? Take a guess. I'll give you another one and see if this works for you. Maybe you'll figure out how far they're shifted from each other. Sine of 30, exact same thing as cosine of 60. Of course, because they add up to 90, right? All right, so let's just prove that. And just make sure you get that part. So everybody, draw your picture for the 30, 60, 90 triangle and figure out the cosine of 60 and the sine of 30. In this class in particular, it's hard to get kids to put their cell phones away because I know you had them out during the news show, and that was totally fine. This is the part where the cell phones need to go away. They can't just be sitting innocuously on your desk, because as soon as the text comes in, you're going to look at it. It's going to be too distracting for you. Cell phones go away. And not in the crack behind your iPad either. Okay, so here's the 30, 60, 90, 1, 2, root 3. Okay, what is sine of 30? Well, it's opposite over hypotenuse. I asked you to memorize this one a long time ago because I said it was going to come up a lot. It just came up again. Okay, sine 30 is a half. How about cosine of 60? Well, if you look at it and you go cosine 60 adjacent over hypotenuse, why is that going to work? Because they share that side together. So it makes sense that they would be equal to each other. And therefore, you really don't even need the cosine button. Whenever you were going to find the sine of 24 degrees, you could have used the cosine of, see what I'm saying? Or vice versa. You could be, if the sine button broke, you could use the cosine button for everything. They're all related to each other. All right. So back to the whole 6 functions thing. There's sine, cosine, and tangent. And I think we've already figured out that there must be a cotangent, and there is. And what are the other 2? Can anybody else name one? Sometimes kids have heard of another function. Yes? Secant and cosecant. You are correct. secant, S-E-C-A-N-T, secant, usually people pronounce it secant, okay, and cosecant. So I'm going to tell you where to put them, though, in your memory. If you just write them in a big list of 6, I would recommend that you stop doing that and write them this way, because there's a certain order in which they will make more sense than others. Sine of 30, cosine of 30, tangent of 30. Let's first figure out those answers, and then I'm going to show you the other ones, and I think they will make a lot of sense to you. Sine, opposite of hypotenuse. It would be handy to have the 30, 60, 90 up right now, so I will. Sine is opposite of hypotenuse, and so it's 1/2. Ooh, I was supposed to memorize that. It came up again. Cosine of 30, adjacent over hypotenuse, root 3 over 2. And then tangent, TOA, opposite over adjacent, 1 over root 3. But Mr. Server, you told me the tangent was sine over cosine. Yeah, I did. Watch what happens. Sine was 1/2 over cosine was root 3 over 2. Watch what happens when I flip and multiply them. I think you know it's going to happen. 1 over root 3. Tangent is sine over cosine. But I know it's probably easier for you right now to just say tangent, TOA, opposite over adjacent, 1 over root 3. Okay, why am I asking you to do it in this order? Because there are certain functions that are reciprocals of each other. The other 3 functions, which make a total of 6, are the flippin' sisters of these. That's my name. Of course, it's not a math name. But you've heard of a sister function, or how about this? I think you've heard of a sister school. Did you know that we have a sister school in China? It's a school in China that is very similar to ours in its makeup and its size and all that stuff. It's sort of like our school, but in China. So it's our sister school. Well, the sister function for sine is cosecant. If I wrote the whole word out, it would look like this. But of course, just like before, we have a 3-letter abbreviation for it, CSC, cosecant. And that begs to say, well, there must be a secant then, right? That goes with cosine. And then what's the one function we knew was going to be there, but we haven't written down yet? Cotangent. That goes here. Now I'm going to ask you to do the cosecant of 30, the secant of 30, and the cotangent of 30. Without any picture, without anything. I've already said what you needed to know to get the answers. Who knows what the cosecant of 30 is? Come on, just it's a gut feeling, but I bet you some of you got it. Okay, then I didn't emphasize this enough. They're the flippin' sisters of each other. Say it louder. 2. Or 2 over 1. How about the next one? Secant. 2 over root 3. And last but not least, the cotangent. Root 3 over 1. Now, you can simplify these, of course. You could just have said 2. Why do I include the 1? To make it clear that I've got 2 sides there. You remember SOHCAHTOA? Sine is the opposite over the hypotenuse. Ka, T, and then O-A. Just like there's SOHCAHTOA, there's also CHOSHAKAO. Watch. Cho. Sha. Cow. Now, that's not awesome as it seems, as awesome as it seems, because there's two C's on the list. You know, before Sokotoa, we had an S and a C and a T. And then Choshakau, there'd be no way to know these two C's apart. So they don't even try for that one. But I did. Why not? But if you just remember them as the flips, you will never have to do a secant problem in your life. Because you won't do secant. You do the sister function and then flip it. See what I'm saying? Somebody on the test says, hey, server, figure out secant of 30. I'll say, no, I'm not going to figure out secant of 30. But I'll figure out cosine of 30 and then just flip it. See what I'm saying? Do you get why your calculator does not have a secant button on it then? See what I'm saying? Why would you even need a secant button? Because you're just going to do what? Not secant, but what? Cosine. Because that's the flipping sister of secant. You got to know that, though. The calculator doesn't tell you that anywhere. You got to know which ones are the flip of each other. Okay, so let's see if you caught that. Would you please figure out the cosecant of 60 degrees? Hint, you'll need your 30, 60, 90 triangle. And you're not actually going to do cosecant. Be rebellious and say, no, I'm not doing it. Instead, I'm going to do this. Okay, did you say to yourself, well, he's telling me not to actually do cosecant, so I'm just not going to do the problem. I hope that's not your actual approach. I hope it was, okay, so to get to cosecant, I'll actually do sine, because that's the one across from it. I'll do the sine of 60, and then I'll just flip it. Okay, sine of 60, well, that's back to this thing, 30, 60. See how often we do this? I mean, I do it 5 hours a day, but it's not trig in my other classes, so at least I only do this twice a day. But I make these triangles so often, and you should too. By now, I'm hoping you've made the 30, 60, 90 triangle probably like 12, 15 times at least. Not today, but since we started. All right, so I'm going to go back and do sine of 60, which is opposite over hypotenuse, root 3 over 2. So what's the answer for actually cosecant? 2 over root 3. Raise your hand if you had that one right. Awesome. Okay. See how easy they are? Because the three new functions are just the flip of the originals. All right. So now, how can we use this? Well, a typical assignment for that I'm going to have you do some problems in that helps you prepare for the test. Might ask you to do any of the same things that we've been doing before with sine and cosine and tangent. Like, for instance, we aren't just doing like sine of 60, we're doing like sine of 120. But then, of course, we could also ask you the sister function for that and then say cosecant of 120. But start just by finding sine of 120. Hint, draw a picture. As soon as you got the triangle in the right spot with the sides and the angles, then the sine of it will be no big deal. Find me the sine of 120. Hint, draw where 120 is, then draw a triangle around it. Okay, here's 120. It's a couple of 60s. That's a way to think of it. 120 gets around to here. Then there's 60 left right here, and I'm going to make my triangle right there. Sine is opposite over hypotenuse, and if I only knew the sides of this, the server didn't tell me the sides. Oh, I did. Because it's a 30, 60, 90, you know it's 1, 2, and root 3. And most common mistake in circle trig, there's a negative right there. Now, did it matter in this case? No, because sine happens to be positive in this quadrant. All right. Sine is opposite over hypotenuse. And therefore, opposite side, root 3 over 2. And there's my answer, root 3 over 2. What if I had asked you for cotangent? Totally unrelated, not the sister function of sine. Cotangent of 120. Would you please figure out cotangent of 120? And I give you every encouragement to say, no, I'm not going to do cotangent. But I'll do something like it, and then flip it. Okay, so for this one, we did tangent, which was opposite over adjacent, but then just flipped it. All right, so now let's go do a little bit of review. Do you feel ready for practicing the hardest kind of question that we could test you on? You warmed up enough? I could go with an easy one now or a hard one. What do you think? What would you rather do? All right, we'll step up to the hardest kind. All right, here's the hardest kind. I'd like you to tell me what two answers you get if I say cosine of some unknown angle is negative 1/2. There are two answers for that. And you got to give them in radians. So in other words, if you were going to say 60 degrees is one of your answers, you better say pi over, what's 60 again? Pi over, ooh, maybe some of you have some memorizing to do. 60 degrees is pi over 3. I'm not saying the answer for this is pi over 3, but maybe it is. Just say your answers in radians, that's all I'm trying to say. All right, check your answer in a moment with the kid next to you, and I hope what you got is a circle drawn with triangles in 2 quadrants of it. That's what you'd really need to do a good job on this one. If you finish that one, then I'm going to give you one other one to try, which is if the sine of some angle came out to 4/5. I know you're thinking, that's not a triangle that I know. I don't know any triangles that have, like, there's the 1, 1, root 2 triangle and the 1, 2, root 3 triangle, but there's nothing with 4 and 5 in it. You're right. On a problem like this, we would not ask you what was the angle, because you won't have it memorized. But we could ask, what is cosine of that same angle? That's a separate problem completely. Do it after you finish the first one, the blue one. And then compare first one first. Compare that first answer with the kid next to you. And then, if you finish that one up, compare the next one. There's often a kid or two that doesn't even know how to start. Let me get you started. I'm not going to finish it. I'm just going to get started. All students take calc is a great way to start, because it tells you where cosine would be positive, here and here, so it can't be there. And it therefore must be where cosine's negative, so like over here. How big are the angles? I don't know. But then I make my little triangle here, and I make my little triangle down here next, and then I find my two answers. I'm going to pause for a moment while you finish that up. You will need one of those. Let me make sure. Sine is 4/5. No, I will. Oh, question? Your answer should be in radians when you're done. No, in this one, remember, I don't know the angle. What I'm giving you here is two sides. Sine is opposite over hypotenuse, so I'm giving you two sides of your triangle. So no, that is not 4 pi over 5. That is just 4 over 5. Totally separate problem, though. Let's finish up that top one first. Ask again, what percentage of you, raise your hand, how many of you are done with the first problem? We're at like 2/3 of you are done with the first problem. All right. Compare with your neighbor first. See if you got the same answer as them for that first problem. Okay, time to finish this puppy up. Once you've drawn this triangle here, did I tell you the angle? No. What did I tell you? Sides. The sides are cosine is adjacent over hypotenuse. I gave you a side of -1 as the adjacent side to the central angle, and the hypotenuse of 2, and that must be square root of 3. And now I know which triangle I'm in. And I always do it this way. The 1 is across from the 30. See how these kind of go together? What's always across from the root 3? The 60. That's a 60-degree angle. But If you say 60, then you're saying the answer's over here, because that's where 60 is. So if this is 60, what we really wanted was how big that was, which was, if you did it in degrees, 120, but I wanted it in radians. So that's how many radians? Think of it this way. Two sets of 60, which they're actually not, 60s are not in radians, but every radian has a degree with it. So 60 is pi over 3. So now that I know I'm in pi over 3s, this is 1 pi over 3, and that's 2 pi over 3. And raise your hand if you had 2 pi over 3. Awesome. And then this spot would be 3 pi over 3, and the next spot is the one I need, is 4 pi over 3. Notice me not having to redraw that whole triangle. I can, but do you get what's important about it is what angle that is? And if you say to yourself, that's 1 pi over 2, 2 pi over 3, 3 pi over 3, that spot's 4 pi over 3, you got the other answer. So it's 2 pi over 3 and 4 pi over 3. Any questions on that one? Okay, then let's do this other one that's talking about sine of theta being 4/5. All right, got my board cleaned up. Where am I? Well, if sine is positive, see, look, there's no negatives here. Sine must be positive. It can't be here and it can't be here. Now, do I have to draw this one twice? Nope, I don't. I could, and you get the same answer both times. Let's just draw it once. Sine is opposite over hypotenuse, right? So I gave you two sides. I gave you the opposite, I gave you the hypotenuse. Opposite's 4, hypotenuse is 5. What's this side? I don't know. Square root of, I know it involves, do you remember this method? Square them both, 25 and 16. But should I add them or subtract them? Subtract them. And then 25 minus, oh, this is coming out to one I know. Square root of 9, which is what? 3. Could you have known it was a 3, 4, 5 triangle? You could have, if you knew your Pythagorean triples. But otherwise, that's how you would have gotten it, that this was 3. All right, now, how does that help? Because now if I do the cosine, I need adjacent over hypotenuse 3/5. Raise your hand if you had that one right. Not as many people. All right, so let's do another one like that. See if you can do this one. If sine of theta is negative 4/7, then figure out what tangent of theta is. Yes, question? Okay. Okay, so if you had put it in a different spot, let me think. We're going to just say that in this problem, in a problem like this, we always do them in the first quadrant. Do not give negative answers. Now, I would have maybe given you credit for it on the test, but I want your standard answer to be, if it doesn't have negatives in it, I'm not going to use negatives in my answer. Okay? We'll just always do it in the first quadrant. That way there's nothing negative, and it's cool. I get what you're asking, but I don't want to spend 15 minutes trying to explain the bottom line. Just use positives on that kind of problem. All right, so this one, it's got a negative. You are going to have to deal with negatives. It has to be in one of the quadrants where sine is negative. You'll never know what angle this is, and it's okay. I didn't ask you for the angle. I asked you for tangent, which is a couple of sides. If you know all 3 sides, you'll be able to find those 2 sides, and it'll be no big deal. All right, so start with what I told you. And I'll pause for a minute while you give this one a try. Okay, can't afford to take 2 log on this thing. If all students take calc tells me where sine is positive, it can't be here and it can't be here. It doesn't. This is an interesting one. It actually, there is an answer where tangent could come out negative or tangent could come out positive. They'd have to tell you, or you could have given either answer. But imagine for a moment, they said that tangent of the angle was greater than 0. Do you get that's another way to say that it's positive? Okay, so If tangent's got to be positive, then I'd have to be in this one. Otherwise, I didn't say anything to give you a reason not to put it here. You could have put it here too. But now that I've said this, I'm going to do it here. Here's my triangle. Sine is opposite of hypotenuse. Opposite's -4. Hypotenuse is 7. Could I have flipped that around and make the hypotenuse negative? No. You're defined that that can't be. This has to be positive. There is no scenario where you can make that negative. Okay, so then I got to find that third side. That's kind of a pain. Square root of 7 squared, 49. 4 squared, even -4 squared, either way, is 16. And then do I add them or subtract them on this kind? Subtract them. And then what is 49 minus 16? It will be 33. So square root of 33. All right. So that's the square root of 33. And now tangent, TOA, opposite over adjacent. -4 over root 33. How many of you had that one right? Okay. If you didn't, look at it carefully. Try to learn from it. Questions? Yes. This is negative. Oh, the root 33. Ooh, you got me. Most common mistake in circle trig. That's a negative because it's going this direction. You're right. Good catch. And since they're both negative, then they would cancel. Thank you for mentioning that. Yes. Yes, we're just using Pythagorean theorem, but we're doing it the fast way. So let's say you had this, 2 and 11. Do you know what to do? Let's do it quick. A squared plus b squared equals c squared. True, but there's a faster way. You go square root of and 11 squared, which is 121, and 2 squared, which is 4. And then you either add them or subtract them. If I had given you the 2 legs, you would add them. Since I didn't, you subtract them. See how fast that is? Yes, it's using a squared plus b squared equals c squared, but it's way faster. Okay. All right. Any questions? All right. So one more kind I'd like to review with you because it's we haven't done these in a while, and this is that rotational motion kind where you got like a bike tire and like a piece of gum stuck to the tire, and it's going around and around and around. Okay, so let's make it a car tire. Imagine that you ran over a piece of gum, and so there's a little piece of gum stuck to your car tire. Do you get that that's going to go round and around and around and around and around really pretty fast as your car is moving along? Let's say that your wheel is traveling at 5,000 RPMs. And your wheel of a car, I would say like 30? I don't know. Does anybody, a car person in here, could actually tell me how big your rims are? I don't know. I don't remember. We need to be going all the way to the edge of the tire also, not just the rims. You know what I mean? Because the rims are in here, and then this part's tire. But let's say it's a 30-inch radius. And the question could be, how fast is the piece of gum moving? Well, hint, you start with 5,000. And you break it up into rotations per 1 minute. Yep. That's the first thing that a lot of people don't do right. They don't break it up into rotations over minutes. Next thing, you have to actually know some facts, one of which I told you you're going to have to know, and there's going to be some of you that have memorized it and some of you haven't. Write down how many feet are there in a mile, and either you know it or you don't. Better to find out today that you don't know it. Yeah. 5,280. Very good. So I'm going to put that in here, but not quite yet. You know why? Because I only want to put in things that I can cancel. Like, what do I want to cancel first? Rotations or minutes? It doesn't matter. You pick. What do you want to cancel? Rotations or minutes? Minutes. All right, we'll cancel minutes. Then I'm putting them here because that way they'll cancel with that. Know what I mean? But what's a fact about minutes that I know? 60 minutes in 1 hour Therefore, it's all about the units on this. If you don't show me these unit calculations, you will not get the credit for this problem. You have to show me what you are multiplying out. All right, can you unplug, please? It's distracting for me. All right, so then I have rotations per hour. I'm close to miles per hour. I just got to get those pesky rotations changed into something else. Do it one step at a time. What is one rotation? Well, that's the same as one what? Circumference. Very good. What is the circumference? You have to have that formula memorized. C equals pi times diameter, or 2r's. That would work too. So one rotation would be circumference. The circumference is pi times 60. Pi times 60. What's wrong with what I just did? I'm going to knock out rotations, but I didn't leave any units. What was the units? Rotations were matched up with what's? Inches. Now I've got units back again. Now I'm in inches per hour. Almost done. I'm sure you've memorized how many inches there are in a mile. Not. So maybe you should do inches to feet first. So I'm going to move this all over a smidge. And I'm going to put in inches on the bottom. Ooh, 12 inches, 1 foot. I would keep going this way where you just keep canceling stuff. And now you ask yourself, am I in the units I want? What am I in? I'm in feet per hour. That's not what I want. Or miles per hour. So then you got to do one last multiplication. And you'll have it. Would you please actually use your calculator? Figure out the answer. Pause for a minute. We give that a try and check with the kid next to you. Okay, one little minor confusion. If you look in Schoology, you will see that I actually hadn't assigned the 6 trig functions to you yet, so I'm actually backing up a day here, but we did do the review also along with that. So you're not going to have much time to work today, but at least I got you caught up. But you never were assigned this. That's what I'm assigning right now in my 2nd hour class. In my 6th hour class actually already did this, but they didn't do much review. So I'll do a review with them today. Anyway, bottom line, your assignment comes from here, which would have been Friday's assignment. And go back in here. You guys click there. I'm going to click the notebook. I'll pause while we get that going. All right, so here's the last thing I want to mention. I wrote them out this way on purpose. And then across from it, I put cosecant. And cosecant of 30 was then flip it over 2 over 1. Anyway, here's the pattern. S goes with one of the new functions that has a C in it. And cosine went with secant. Notice C went with S. The C's and S things works pretty well as long as you can keep track of the last one, because there are 2 of the new functions have a C in them. The last one is tangent goes with cotangent, and therefore I think those 2 kind of feel like they should go together, tangent and cotangent. The others are S's going with C's and C's going with S's. All right, your assignment is to do the first 2 pages of this one's assignment. And you guys may leave, and I'll show you as I finish up here and finish my recording where those are. If you got to go, you got to go. That's how I understand. I'm going to show you where the first 2 pages of this assignment start. All right, there. And right there. The first 2 pages of the new assignment. And that's all I think you need to do for tonight. We'll do a big, huge review tomorrow, too.